All right, welcome students. Welcome to Thursday, TOC 510. And we're going to take a lot of what we have learned, kind of reinforce it a little bit. If you don't have your worksheet printed out, I would really suggest that you get either graph paper or try to draw it out as best you can. But let's get started. All right, so again, you should have 510 with you. It can either be on your computer that you're flipping back and forth with it, or it can be right in front of you if you could print it out. Oops, I'm still getting used to this. All right, so next slide. Okay, again, pause this video whenever so that when we go over it, you've already tried it first, okay? That said, directions. Describe the graph of the quadratic function below given in table form. All right, so first I noticed that it has that kind of double, like that reflecting quality, where I have a 3 here and a 3 here, an 8 here and an 8 here. And if you notice, this only happens on the y, all right? So, in fact, actually, if I were to graph that, I could just do a sketch of my graph. And I know at 0, it's way up top. I should probably do a different color. All right, so at 0, it's way up top. Then at 1, it goes down pretty low. At 2, it's at 0. All right, we're going to pretend like that's okay. At 3, it's at -1. At 4, it's at 0. Okay, I should have drawn this a little bit better. At 5, it's at 3. Ooh, that. Hopefully you guys can do a little bit better than Miss Cram on this app. But these two right here, that big blob over there, and this over here should be at the same level. And then the last one should be way up high, matching the first big blob I had. All right, so again, this is kind of a wonky graph, but I could do that just to kind of see as a sketch what it would be. All right, so the lowest point is where the lowest y value is. So I know that this is the vertex. All right. I also know that since it kind of goes from being up to down, that this vertex is the lowest point, or the minimum. Okay. Now, what else do I know about this? So I see that it opens upward. Opens up, okay? If I were to write this in any of the 3 forms that I've learned, which is standard form, vertex form, and factored form, it would start with a positive, right? So the x squared value would be positive. If the x squared is negative, right? So let me just write that down. So if I have like y equals x squared or something, then that would be positive. And if I had y equals negative x squared, that would be negative, right? So even without graphing it, I know that it opens up because the y values has a minimum, a lowest y value, not a highest y value. All right, so let's go on. I'm sure that there are plenty of other things that we could annotate here. Actually, wait, let's do one more. Here I have my y values are 0, and these are the x-intercepts, also called the roots, also called solutions, and what else are they called? Zeros, because those y values are zeros. Cool. And while I do that, let me just say when x is 0, I have my y-intercept. Y-intercepts do not get as much love. They don't have as many interesting names. Okay, now let's go on to the next slide. Okay, so for all of these examples, what they're asking you to do is to, I think, annotate. Actually, let me see. I need to look at the worksheet again myself, which is good for the directions. So the directions say annotate the key features of each quadratic function on its graph and table. All right, so let me do that first. So first, I see a vertex right here, and that is a minimum. And let me find that point. So that's 3, -1. And again, I see that the y value is lower than all of the other y or f of x values. So this is my minimum. So even without looking at your graph, you should be able to look at that table and know that this is a minimum vertex. And again, if it's a minimum, the parabola always opens up. It looks like a U shape. All right, so now let's see. We have 2 x-intercepts or zeros or roots or solutions, right? So I've got these 2 right here that are x-intercepts. And let me find them over here. So I've got 2 and 4, okay? And now, what else do I know? I know, that there is a y-intercept up here, right? It looks like if I extended this, it would hit the y-axis really soon, right? So that would be your y-intercept. I wonder if I can see it over here. It looks kind of like it's either 7 or 8. Okay. I see it right here. The x is 0, so I know for sure that this is the point that I can't see on that graph. So this is my y-intercept. Oh, and let me label these guys. So these, let's just say here. All right. Okay. My axis of symmetry, remember, always goes through the x value of your minimum or of your vertex, right? So my axis of symmetry is x equals, and again, 3 is the x value for your vertex. So x equals 3. Okay. Remember, it's always important to remember the axis of symmetry is an equation. It's an x equals equation. And vertex is a point. Sometimes people get those a little bit confused. All right, and then it asks you to give an approximate or a possible equation. All right, this does not have to be perfect. If you were to put this equation in your calculator and you get the table values that we have here, excellent, fantastic. But as long as it has the general shape, right, this general shape that is here, with about the same vertex, right? So as long as it's close and gives you that same shape going up, and maybe it's moved to the right or to the left of the origin, or up or down from where that parent function would be, as long as it's close, then that's what we're asking for. So we don't really even know for all of them how to get an exact equation, all right? So I'm going to show you 3 ways. One is the factored form. So I'm just going to write it up here, factored form. And I'm doing it in green on purpose because factored form deals with my x-intercepts. So I have y equals, and I'm going to put in parentheses, and just like in vertex form, or whenever we have that number that's being plus or minus, it's kind of the opposite of what you would think. So here I've got a positive 2 for one of my x-intercepts. I'm actually going to put minus 2. And now the other one is a positive 4. My x value here is a positive 4. I'm going to put in x minus 4. Okay? So again, maybe that's exactly it. Maybe I got lucky. Maybe it's a little bit wider, a little bit narrower, So you can play around with that a little bit. But I know for sure that however it's factored, I definitely would have x minus 2 in one of my pieces that I've been breaking up and minus 4 in the other one. Okay, so that part is definitely accurate. Okay, and also it's a positive in front of the parentheses, right? If it was flipped upside down, then I would start with a negative there. All right, so now let's see, what else should we do? Let's do vertex form. All right, so we've got vertex form. And if you thought, hey, why did she do that in red? It is definitely because I did this vertex, right? Right here, that vertex is 3 at -1, okay? And so here, again, I'm not going to put a negative because if I put a negative, that means it goes downwards. So let me erase that. All right, so I know it's going to be a positive. So I'm going to write x. And again, the x value of my vertex is a positive 3. But I always put the opposite of what I would think. And you don't really have to remember that. You can always just put it in your calculator. As long as you remember it's either +3 or -3, you should be fine. And now I'm going to put that squared. Remember that squared says, hey, this is a quadratic function. All right, and now the vertex has moved down 1, so this y value, and that's just exactly what we would think. Okay? Again, does this have to be perfect? Does it have to match your table exactly? No. But when you put it into your graphing calculator, it should look similar to the parabola of function A. All right, so now that leaves us with, I think, standard form. All right, try and think of the color I'm going to use. All right, standard form is definitely in blue because standard form really lets you know what this y-intercept is. All right, so I know that it's going to be y equals, or actually, you know what? These should not be y's at all. These should actually be f of x's because this is an f of x. Let me actually change that really quick. All right. So we have an f of x here, and in green, an f of x there. Okay. So this is in function notation. Remember that f of x, or anytime you have like g of x, m of x, all function notation. All right, so let me get back to the blue. So I know I'm going to have something that's positive for x squared, right? Maybe there's a number in front, maybe not, but I know absolutely for sure it's positive. And now I'm actually just going to put a question mark here. I have something here that has an x, but I actually don't know what that is. What I know for sure is that my y-intercept of 0, 8, if both of these x values were 0, I would still be left with a +8 at the end. So this, I am absolutely sure, would be here in standard form. Okay, so just really play around with those. Again, don't stress about it. Don't just be like, oh, I have no idea how to write an equation. The main point is I want to see that you're making some connection between factored form being connected to the x-intercepts. Oh wow, I'm making this so messy. Sorry, guys. That your vertex is connected to your, your vertex form is connected to your vertex. And that standard form, and I already have that arrow, so luckily I don't have to make it too much messier, that your that your standard form always has the constant term, the one without the variable, matching your y-intercept. Okay, so you might have to play that one again. We did a lot of work there. Okay, last slide actually. So this one is towards the bottom of your worksheet. And they just want you to state one key characteristic about each quadratic. So for the first one, right, you can look and know that it's in factored form. Okay, so I'm going to look at all the ones that are in factored form. So I see A is and E is. So my x-intercepts would be, and remember the y value is always 0. So I'm only looking for x values. So here I see x minus 4. And remember, it's different when it's with the x, it's different than what you would think. So this one would actually be a positive 4, and then the y value is 0. And the second one, I don't see anything. It's just an x. So that's the same as it being like x plus 0. Okay, if you don't see anything with the x, it's going to be 0. So the other x-intercept is at 0, 0. Okay, and for this one here, I know that my x-intercepts are going to be the opposite, right? So this would be a negative 3, 0, and a negative 5, 0. Again, if they want you to go from one form to another form, or they want you to state what the x-intercepts are or the y-intercepts, graph it. Graph the thing in your calculator. That is one of your biggest tools that you can use here. So if they give you something in standard form and an answer choice is in factored form, put them both in your equation, and if it's equivalent, it should give you exactly the same parabola, right? It should look just like one parabola right on top of each other. All right, I digress. So let's talk about vertex form. So I see a vertex form here and here. All right, so vertex form. All right, still getting used to this, guys. Okay, so my vertex form here, I know that my vertex would be this with the x. Remember, it's the opposite of what you would think. So my vertex, which is a minimum, right? Remember, there's no negative in front of here. There's no negative, right? I'm going to erase that. So if there's no negative, that means that it opens upwards, which would give us a lowest point as a minimum. All right, so my vertex is -1 from inside the parentheses with the x and -1 from the outside. Again, graph it. Make sure that that's correct. Now here, I'm not going to write as big, but I do know that this is a minimum, right? And I don't see anything inside the inside of a parentheses, right? Like up with B, I saw there was a +1 with that parentheses, so I did the opposite. Here, there's nothing, so that would be at 0. And then I see a -16 out here, -16. Okay, so it really just shifted down 16 spaces. All right, sorry about that. Okay, so now the last one is standard form. So standard form is here, standard form. Standard form is also here, okay? So this one's kind of an interesting one for D, because when I have no term in for X, right, in that same parentheses, it's both. It tells me that that number would have been 0. And it's also in standard form because I've got the highest exponent written first, and then all the way till I have 16, which is my constant. All right, let me erase a little bit of this, make it a little neater. Okay, so now with my standard form, I know that my y-intercept is, so here I've got my y-intercept, so these x's would have to be 0. So my x is 0, and my y-intercept would be at 0, 10. Okay, same thing here. My y-intercept would be at 0 when x is 0, right? And negative 16, because this, let me do that again. All right, because this negative 16, if the x were to be 0, then negative 16 would be my y-intercept. Okay, well, you guys get the point. That's the y-intercept. Okay. There could be some other characteristics that you've seen too, like the parabola opening up, the parabola opening down. So play around with it. All right. That is it. Oh, I didn't make my question slide. Sorry, guys. So if you have any questions, concerns, comments, please, please, please write them down. Your notes, your lovely notes that you've taken, make sure that they go in the note tracker. So you just have to take a picture of your notes, send them to yourself in an email, download them, and then you can upload them into that Google Doc that's titled Note Tracker in Google Classroom. It is not as complicated once you do it a couple times as it sounds. I promise. Okay, that's it for today. Thank you. Bye.